Assalamualaikum everyone. Thank you guys for joining this session. I welcome you all in today's session where we are going to learn about the Gamma 3, which is the open source large language model from Google. We are going to see how we can configure this Gamma model in our own in our own server, and you can just simply use it by just without using any API key. So we're going to see how we can create any Gen AI application using the Gamma 3. So myself, as Ali has already mentioned, I'm AI engineer working at Data Techcon. I have around 6+ years of experience in creating machine learning, deep learning, Gen AI applications that help businesses to scale their process and automate their manual process. So before proceeding, we'd like to have the understanding, those who are joining our session for the very first time, those who don't have the idea about generative AI, what is generative AI, how it is different from traditional machine learning and deep learning. So we're going to see first understand what is generative AI. These days, everybody's talking about Gen AI, what it is, how it works. So generative AI is a paradigm that is not like the previous machine learning and deep learning model. What we do in our machine learning and deep learning model, we pass our data set. We generate, first of all, we gather the data set, we prepare the data set, and we pass the data set to our machine learning or deep learning model. And those model learn from your data. But in Gen AI, we already have available models in the form of either APIs or in the form of open source weight. We just simply utilize this. They are ready to be utilized. We just simply configure it and we utilize it. If we take an example of ChatGPT and Gemini, it is trained over the data set over the internet. So it is already trained. We just simply call it. We just simply use it in our applications. So generative AI is not like the traditional machine learning modeling. It is not like which is going to predict. It is like generating a context for you. If we want to generate a text, if we want to generate an audio, if we want to generate a code, if we want to generate a video, it can help you to generate. So generative AI leverages transformers architecture. In previous machine learning and deep learning models, they don't have the transformers architecture, meaning they have the capability to understand what my user is trying to achieve. Let's say you are using the Gemini, you want to generate an image using a nano banana. So, but you enter a very long prompt. So what you are trying to say to your model is able to understand. But if we talk about the machine learning model, can they do the same thing? No, they can't, because they don't have the transformer architecture. The transformers architectures allows your model to understand what my user is trying to achieve. They have the special mechanism that is called attention mechanism that pays attention to the input of the user, what my user is trying to say, what my user is trying to achieve. So let's say if I have to generate an image of the humans that are doing XYZ activity, so that I can input in my prompt, and my model, my whatever the model I'm trying to use, it will be able to understand because of the transformer architecture. So in machine learning and deep learning models, we don't have the architecture of the transformer. That is only available in the generative AI models. That is the transformer architecture that has different components, including tokenization, embeddings. We have the intention layer and different layers of normalization that allows your generative AI model to understand the context, the input context of the user. Large language models, those who are not familiar with the large language model, what are they? They are trained on trillions of tokens. Gen AI is also a large language model. Gamma is also a large language model. Google has many large language models available. So the large language models trains on millions of tokens, capturing the vast complexity of human knowledge and language nuances. So if we talk about the Gemini, it is trained over the data set available on the internet. So it is trained on the vast amount of data set. Few shot learning means you have the large language model available. We can train the machine learning model for our own customized use case, but we cannot do the training. We cannot retrain the large language model, any large language model, because the problem is it's quite resource extensive. So the only way to handle the output of your large language model is through the few shot learning technique. This is a technique that allows your large language model to explain what I have to do. Let's say you are solving a problem of classification. You have to perform the sentiment analysis. You can just simply show the few samples of sentiment analysis, for the examples of negative feedback, negative output, and the positive output, and the neutral output. So your LLM will be able to generalize the next coming input. Is it what's the sentiment of this input? Engine of reasoning. LLM is working as an engine of reasoning in many applications. It works as a backbone of the agents. If we are creating the agents using any framework, so LLM is the backbone. Without the LLM, you cannot perform your task from your agent. So it handles the complex logic explanation. If you have to generate a code, if you have to do any certain task, so LLM is the backbone of any agentic framework. Google have different LLMs. First of all, the Google had the Palm 2 that was very high efficiency in reasoning. That was very good in reasoning. That was the first. That was the very earlier language model from the Google. Then we had the Gemini. Gemini is as we are using these days. Now we have Gemini 3.0. We have different version of Gemini Ultra, Pro, Flash according to your use case. You can pick. And the Gamma is the open weights. What is meant by open weights means it is open source. You can download this model in your application, in your system, and you can just simply use it. You can customize it. If you have to perform the fine tuning, you can fine tune it. If you have to perform any kind of any kind of task with this without using the API key, you just simply configure this language model in your own server, in your own machine, and you will be able to use it. So that is good for developer research, and you have the custom edge apps where you want to just simply host your application. You don't have the connection with internet. These LLMs is already trained. This Gamma is already trained, so you can just simply configure it in your application and you simply use it. So without using any API key, without using the internet, you can also use it. So the power of input capacity. So now these LLMs have a very input capacity. They can take up to 2 million of tokens as an input. What is meant by context window? If you guys have used the Gemini in the early days, the input window, that means you cannot pass a very big input text to the Gemini. You must have to restrict the input. So, but with time, those models are getting updated. Those models are evolving. So now we have the Gemini 3 that can take up to 2 millions of token as an input, means you can pass a very long big input. So your model will be able to understand and generalize the output according to it. Gamma 3 native multimodality. You can perform different type of tasks with Gamma 3. You can perform the visual input. You can pass the input image. You can use it as a streaming as well. You are streaming your application. You have an application where you have a streaming data. You can use the Gamma 3 as well, where it can process the input streams on the runtime. It can process the high resolution images as very well, and it can just simply generate the output for you. Audio stream, it can work with the audio stream as well, and obviously it can work with the text as well. So let's jump into the more detail about the Gamma 3. I have already installed the Gamma 3 in my local through the Olama. So what you guys can do, if you have to configure this Gamma 3 in your own server on your own machine, you just simply go into the internet, just type the Gamma 3. It will open this web link for you. Just go over there and select which model you want to use. So there are different models of Gamma. There are different variants of Gamma available here. They have the different input code, window text. You can just simply select according to you. So Gamma 3 latest can process with text and images, but Gamma 3, who has just 270 million parameters, that can only proceed with the text. And the Gamma 3 with 1 billion parameters can only process the text. And the Gamma with 4 billion parameters can process the text and images as well. So I have configured the Gamma 3 with 12 billion parameters in my local already. The size of this model is 8 GB, and we can pass 128K input tokens to process at one time. So I have already configured one. So once you get this, you can just simply go on to this, download this, and you will be, once you download the Olama, you just simply open your command prompt and just simply run this command. So you will be able to download this Gamma 3 on your system. So I think there is a question. Which Gamma model is compatible? Okay, so basically Gamma is a separate model. You are going to use the Gamma when you don't have the internet, when you want to fine tune your model, your specific use case. So Gamma is a separate model from Gemini. You can use the Gemini in your application. You can use the Gamma and the Gemini as well. So let's say you're using an from context window point of view, which model is compatible with Gemini? I didn't get your question. from context. So both have the different context window. Gamma have different context, and Gemini have different context input. If you can elaborate your question, I would like to answer it again. So I have already configured the Gamma 3 with 12 billion parameters in my system. So I am going to just simply run my application. I'm going to pass the prompt and we're going to see how it's going to work. So, but before this, let's have a detailed understanding about the Gamma. Without GPU, no, sure, it will not work because in my system, I don't have a GPU. I'm going to show you the example. I'm going to show you the runtime, how much time it took, the processing power it took. So without GPU, you cannot run it. But if you have like good GPU, good processing power, you will be able to get the response from this Gamma model very easily. So Gamma is an open source model from the Google. We can just simply use it. If you have your own customized application where you don't want to interact with the internet, where you should have a own prime, your own large language model. So Gamma is the best choice for this, and Gamma has different versions. So artificial intelligence has evolved rapidly in recent years, particularly with the development of large language models. Yes, we are seeing every month we are seeing a new large language model available in the market. So that can understand and generate a human-like text. Yes, that is we are seeing. It can understand the context of the human and generate the human-like text for the human. These models have transformed industries such as healthcare. Every industry is now transformed, either it is a banking, either it is a healthcare, either it is a finance, either it is a education. In software development, now we have the code assistants, just like anti-gravity, cursor, and many other code assistants which are being used to generate the code for you. So you don't have to write the code manually. Those coding assistants are generating a code for you. So one of the major contribution to this development is Google. Google is always ahead in this, which has been investing heavily in AI research through AI Research Division, Google DeepMind. Among the latest innovation from Google is Gemma. Gemma, a family of lightweight. So let's say if you have any IoT edge devices, you want to run a very lightweight model. You don't want to depend on the costing. You just simply want it should be an open source model. So Gamma can use a family of lightweight open weight language model designed to help developers and researchers build AI powered application more efficiently. So if your application has, if your server has a good resources, so this Gamma is going to be a very good use case for it. Gamma models are based on some research and technology used to develop Google Gemini, Google Advanced Google Advanced Multimodal AI system. Gamma models are designed to be powerful yet efficient, allowing developers to run locally or in the cloud. Either you can run locally or you can also install on the cloud while maintaining high performance, unlike extremely large language model that requires massive computing infrastructure. Yes, it is totally different from other language model that requires a high computing resources. Gemma models are optimized for accessibility, enabling startups, researchers, and independent developers to build advanced AI systems without needing expensive hardware. You don't need a very expensive hardware. Even my system is not very expensive. We don't have very good hardware, just 16 GB RAM and not any graphic card. I'm just still running my Gamma model with 12 billion parameters on my system. The release of Gamma represents Google commitment to democratizing AI development and promoting the responsible AI and transparent practices. So architecture and key features of Gamma. Let's understand what is the architecture and the key features. So first, if we talk about the architecture, all the variants of the Gamma are backed by the transformers-based architecture. Transformer-based architecture has two components, encoding and decoding, and the main component and the main feature of the encoding, it is the attention mechanism. Inside the encoding part, there is another component which is called attention mechanism. You enter your prompt to Gemini. I'm more emphasizing about explaining you about the transformer-based architecture because tomorrow we'll have another language model. We have another open source model. They will have the same architecture backed by the transformer. Only the parameters will be changed. Maybe any other company launch this. So if you understand the architecture of the transformer very well, you will be able to understand how you can fine tune, how you can get the better accuracy, better output from your large language model. So based on the transformer architecture, they have the self-attention mechanism. They have allowing the model to understand, to pay attention to every input, what is important in the input prompt, and focus on that and ignore what is not important in the input. So just like you enter a very huge line of code to the Gemini and you ask, can you please find out the error? Now, Gemini job is to find out the error. He is more focusing to find out the error. His job is to find out the error. This is the context. This is the because of the self-attention mechanism, Gemini will be able to pay attention what I have to do. My job is to fix the code, not to generate a code. I am here to fix the code, fix the existing code. So based on this, model is able to understand the context. So Gemma models are designed to provide strong performance while maintaining efficiency and scalability. They are part of modern transformer-based architecture, which has become the standard design for most advanced language models. So as I mentioned, every language model is backed by the transformer-based architecture. So transformer-based architecture have the encoding part, which when the input goes in the language model, they encode the input. On the other hand, it is the decoding part. So these are the two main components, but inside the encoding, there are many other components. We have the tokenization, we have the positional encoding, we have the self-attention mechanism. Model architecture, Gamma models are based on transformer architecture introduced in the landmark paper. Attention is all you need. Maybe you guys have already read that paper. The architecture allows model to understand the context in text by using the attention mechanism. The transformer architecture enables Gamma to produce language in a parallel and scalable manner, making it suitable for many large language processing tasks. Gamma inherits many improvements developed by Gemini models, including optimized training techniques. You can train it to optimize. You can use different optimizing training techniques using just like low rank. You can just simply use it PEF model, efficient attention mechanism, and better token processing capabilities. These enhancements allow Gamma models to perform well with fewer parameters compared to extremely large language model. Even if you go with the model of Gamma, we have the few number of parameters, still it can perform well as compared to the extremely large language model. So we have different sizes of Gamma. We have seen over the website of the Olama. Gamma family has different type of model. First model is 270 million parameters. A very lightweight model with approximately 270 million parameters with has a token input context windows. You can pass only 32K input token. It supports text processing, ideal for experimentation where your resources are very low. You want to perform the deployments on a very small scale. You can just simply use it. Gemma with 1 billion parameters, compact model with 1 billion parameters still have the token window of 332K, which is a very small as compared to the other versions. 4 billion parameters has a very big input context window, which is 128K, which is a really big input which you can pass. 12 billion parameters, Gamma with 12 billion parameters, are large and more powerful model, 12 billion parameters and a 128 context window capable of handling text and image tasks with stronger reasoning, contextual understanding, and generation capability. So it can not only generate a text, it can not only produce a text for you, it can work on the images input as well, it can work on the stream images input as well, so it can perform the understanding of the context. Gamma 3 with 27 billion parameters, the largest model in the Gamma family with 27 billion parameters, also has the 128 context window. It supports multi-model. Multi-model means, again, it can work on the text and images, and it is designed for complex EA tasks where you need the deeper reasoning, where the application has high working on the high performance, you can use it. I think we have a question. Well, those who are new, I am just making sure everyone should be able to understand about this Gamma. We know about the Gemini. The reason of explaining this documentation, we should have the understanding how this Gamma model is working, how the different variants of the Gamma we have here. The Gamma 3 have different variants, so we should understand if we have to choose the right model for you. So you should be able to understand which model I can use. Key features, it is open weight. What is meant by open weight? Can anyone answer this in the chat box? What is meant by open weight Gamma model? Can anyone explain what is meant by open weight? What is the meaning of open weight? Why do we have this open source gamma model? Okay, so the open weight means you have this gamma model that is trained on the certain amount of data set. But let's say you have your own use case where your model should be able to pass over my data set and should be able to generalize well on my data set. So for this, the whole retraining of the model is really difficult because even I just still download the Gamma 12 billion parameters on my system. And I'm trying to just simply pass the prompt. It is taking a while. So just imagine if you go for the retraining the model from scratch, it's going to take many months and going to require many resources. So instead of retraining, we have a mechanism called fine tuning in which you just simply pass a very few subset of the data, the model. And these models are really good. Let's say if your data set is 100, from 100% from 100 samples, you just simply show 10 samples to your models and ask your model to learn from these 10 samples. And when you're done with the fine tuning, you should perform that task. So fine tuning is like that. You don't pass the whole data set. About the whole data set, you just simply pass the few samples to your model. And these models are that much efficient. They are able to understand how the data looks like. They will be able to understand how the rest of the data will look like. So the open weight means you can fine tune your model on your own data set. Efficient performance, unlike extremely large language models, requires high GPU clusters. Gamma model can still work where hardware resources are very less. Developer friendly ecosystem, very easy to fine tune. If you have your application working in TensorFlow, PyTorch, you can just simply easily integrate in your application. Applications, you guys can already understand the applications are really wide. You can use it for the text generation. You can create the question answering. You can create the chatbot, conversational agents, text summarization. You can go with this. I'm going to show you all these examples with how you're going to perform the text summarization. If you have the your developers, you can just simply integrate the Gamma models into the coding assistants. You can just simply perform the coding tasks. You can perform the debugging. You can generate the documentation of your code, whatever the task you want to do. Retrieval augmented generation RAG, which is very famous. Gamma can also be integrated with your RAG. Let's say you don't want to fine tune. Instead of wasting your time in fine tuning, you just simply want to simply create your vector database. And whenever user asks a question from your Gamma model, if Gamma model knows it, it's perfect. It will answer this. But if that answer of that question is not inside the memory of the Gamma model, so Gamma model will refer the vector database from where it will retrieve the right answer of that question, and it will generate a task for you. So developers can combine the Gamma with the different vector databases, just like you can easily use the Facebook AI similarity search. That is a very famous algorithm for performing the search similarity search from your vector database. If you have a Pinecone, you can easily integrate the Gamma model with the Pinecone. If you have a Chroma, you can easily use it, the Chroma, with your data. So for the education purposes, you can use it according to yours. So I am going to, okay, before I proceed with the coding, I just want you guys to, okay, yes, you can find it. So if you guys don't have the Gamma model, you can choose any Gamma model according to your ease, according to your system requirement. Even if you go with the 20 to 70 million parameters, it is also fine because we are going to just simply perform the prompt engineering with this one. So go over the Olama and just simply get the Gamma, any model from the Gamma 3. Download the Olama. Either you can open the Olama from here or you can open from the command prompt. So once you have I have already installed the Gamma 3 with 12 billion parameters. So let's ask a question from him first, then we'll proceed with the Jupyter Notebook. Hi, can you explain me about the Gamma 3 with 12 billion parameter? What task I can with this model? Okay, so it is generating. You guys can see it's taking a while to generate. It's not really fast because it's using my compute from my system, so it's taking a time to generate. Okay, so but obviously the TPS rate is very high, the token per second is very high. It's not really efficient generating, but still I can use in my local system to generate the output where I want to host my own application without using any external language model I want to install or language model in my own system, in my own server. I can just simply use it. So which is, so it's just simply returning a. So okay, it will keep generating. Let's move further. So we are going to install a few libraries. We are going to install the Llama, and we need the pip version of this one. We're going to install this, and we are going to simply import the libraries. I'm setting here my model is Gemma 3 with 12 billion parameters. The temperature is set this one. The few parameters we have the top K to top P. These values I have set here. I am going to pass my own data set. I have the few examples available here. I want to query the data from this one. So I just simply set the data path from here. You guys can just simply set your own data set. I just pass the receipt here. I just simply pass few information regarding the OLAMA. You guys can pass your own text document. Here I'm passing the README file. You can pass your own file, whatever the file you want to pass. You guys can simply set here. So I'm defining a function of the model where I'm going to just simply set the rule, and I'm going to set the system prompt, and I'm going to pass my input prompt here. I'm setting the temperature, I'm setting the penalty, I'm setting the top K, top P, and the min P, all the parameters. So upon defining the function here, I'm going to just simply pass a very long range of lyrics prompt. Compose original hip hop song lyrics that captures the 90s aesthetic while exploring the artificial intelligence and technological feature requirements. I am passing and providing him the very straightforward commands and the instructions to him. Maintain the authentic 90s hip hop linguistic style, slang, flow, cultural references, thematic focus, demonstrate understanding of 90s hip hop. And in the last, evaluate your prompts against these criteria. I'm passing him, you have to perform these criteria as well. Originality of technological narrative, authenticity of 90s hip hop voice, rhythmic potential. So this is my input prompt. I'm going to generate lyrics. And once I have already executed this, and if you guys see this, the output here, when I run this, it generated the text on me, but it took that 23 minutes to just simply generate the output for me. It took CPU time, and it took all the processing time, and it generated the output for me. So I am not using any API key. I am not using any model from the cloud services. I just simply configure the model in my local, and I'm just simply calling it. It has generated a very long input output for me. I am just simply choosing it. Okay, evaluation criteria. It has also provided me the evaluation criteria. It is explaining me on which basis it is performing the evaluation. Coding assistant. Okay, that was a simply prompt. Now we can go with the coding assistant as well. Your task is to write a Python code that accomplishes the following coding task, and please follow these guidelines. Write a complete functional Python code that solves the given task. Use the clear descriptive variable names and follow pip style Python Python 8 style guidelines. Include a doc string, just like when we create a function, out inside the function we create a doc string, so if someone is reading my code, he or she will be able to understand the code. Add inline comments, that is really important. Implement the appropriate error handling. When error handling is involved, it should be there. If applicable, consider the edge cases and handle them approximately. So I have provided the 6 instructions to this Gemma 3 with 12 billion parameters. Write only the Python code without any explanation. So I'm just simply giving him a real straightforward prompts. You have to really generate only the Python code. So now it is a system prompt I have set here, coding prompt, which I have set here. Now I am going to pass the input prompt. Generate a data set of wealthiest people of each continent for each person. So it is just simply each person should contain the name, gender, wealth in million USD continent. The data set must contain at least 10 examples. So I just simply asking him. So it has written a code for me where it is pandas and numpy code. It is a function. Inside the function, I have a very well documented code, generates our doc string as very well. And it has the if else condition, and that's another function, and it has the main function if main where it is calling the function and it's generating a code. So if you guys copy paste this code, you will be able to see it is really generating a code for you. So whatever the task you're trying to perform with this Gemma, it will is generating a code for you. It is working as a coding assistant as well. Next one I am here, generate, I'm asking him to generate a data set for me. So it is a function I am using here. So it is simply working for me. I can see the code is really working for me. Labeling the data, today my PC was nearly compromised. With just one click, I installed malicious code extension. Luckily, I was saved as my PC does not run on Windows. Hackers are getting smarter and not just targeting beginners. Here's how they do it, how you can protect the data. So there is a different tweets. I have the second tweet is finally I got everything. The cloud, I'm now paying the 10 times less for better infrastructure. My AWS bill was 1400 per month. I got it down to 120 for literally better. The fear servers, fear of managing servers has priced 10 times monthly infra bill. So there are different type of tweets we have. We have different type of tweets. We are just simply passing in the list. Now we have your task is to analyze the following text and classify it based on multiple criteria. Provide your analysis as a JSON output. Use only the specific categories for each classification. First category is the target audience, general public, professionals. In the target audience, what are the target audience? The sentiment is formal, informal, complexity. What is the complexity of the tweet? Main themes or topics. So this task is getting quite really difficult. So we have multiple things to do this. So let's see how our model is able to do this. So it has just simply performed the today my PC was nearly down. So it is the audience is for the adults. The tone is quite serious. Complexity is quite intermediate. Topic is from the technology. Another second was the professionals, positive. So it has just simply classified your data. So you can see how the complex your task was. For this, it took the 5 minutes to perform this whole process. So because as you okay, so once you start running your model in your own app in your own machine, so with the time the processing time will get low. The first time it will take a longer time to process your input, but after the first once it is done, it will take the less time. So it is generating a very well task for me. I can just simply say summarize, so it can work as a summary generator for me as well. So I can just simply pass the input and it can just simply generate a summary for me. So that was it. We have seen how Gemma models are can be used as your open source model. You can just simply fine tune it. You can call in your own machine. You can install in your own machine. You can configure it. If you want to fine tune it, you can also just fine tune it by providing a very few sample of data set and whatever the task you're trying to perform. Let's say you have a data set samples of thousands of samples of the images. Just you can pass 20 to 50 images from that sample, just a diverse sample from there, and you'll be able to fine tune with that. So we just simply pass the prompt. We just simply ask him few different kind of tasks. Work as a classifier, work as a coding assistant, work as a summarizer. But you can just simply leverage it according to your own use case. You can just simply customize your own use case, and you can just simply use in your own application. So if you're a student, you are working on your FYP, you don't have the credits to use the Gemini or the OpenAI, you don't have to worry about this. You can just simply install these models according to your system specs, according to your graphic specs. And just simply configure in your application. You'll be able to create a very good Gen AI application in your own for your own FYP. So if you guys have any question, you can ask. Okay, so if we are keeping it in local, will that LLM data or search go outside of our network? No. So that is the reason we have the use cases where you don't really want your search from the LLM to go over the internet. Now this model is not connected with the internet. Even if you turn off your internet from your machine, it will know. It will all still answer your question. So that is the good thing. You can easily customize on your data set, so you don't have to worry if your data is going to lose. Or where you have the use cases where you really don't want to use the language models where it's the API keys. So you can install on your own servers, on your own app machines, so you don't have to worry about the connection with the internet. It will be still answering your questions. Anyone else? Okay, a question from Faisal is, I have a strong machine learning and deep learning background and good grip in sklearn. So, okay. So now if you have good grip and understanding about the machine learning and deep learning, now you should proceed with the generative AI. You should start with training your own agents, how you can just simply set up your own agents using the ADK. You can use the true AI, understand about the lang graph, lang chain, how you can simply use the prompt engineering, few short sample, one shot learning, how you can just simply create your application like that. Just like we have seen the Gamma model demonstration today, set up the any language model, start with the lower model, just like we have a 270 billion parameters, and start to configuring your own machine. Create any small kind of application through this, and you'll be able to understand it very well, and just simply keep expanding your expertise in this domain. Explore the other frameworks, explore the other language models. We are talking about the language models of the Google. Explore the other models, Mistral, how you can use it. The DeepSeek is also open source, how you can just simply fine tune it, how you can just simply integrate with the retrieval augmented generation. So there are many things you can easily go on with the generative AI roadmap. Understand about the RAG, understand about the vector database, understand about the language models, understand about very well about the transformers architecture, how they work, understand very well about the attention mechanism, get the detailed understanding about the self-attention, encoding, decoding, how it is different, how encoding is different, and how decoding is different. So understand about these architectures, and just keep eye on all different kind of language models. The use case is quite same. Let's say we are doing this use case with the Gemma model. We can do the same thing with DeepSeek as well. The models are different, but the use case are same. So, so if you understand these things very well in detail, you'll be able to do this. Okay, actually, Bashir, no, unfortunately, we can't, because I was trying to create a very small use case of using the agents, but still I have the limited compute resource. As you can see, when I was running the Ulama model, I was just running the Gamma model on my server, on my local server. It was taking a while to generate the output for me. So because of this limitation, I was not able to get that use case ready for you guys. So kindly suggest the FYP most trending ideas for empowering daily life activity. Well, there are many. You should just have to explore your own, how you can just simply use the generative AI in your, okay, uh, in your own application. Just like we are these days, everybody is using the generative AI. Every product is backed by the generative AI. If you pick any healthcare, if you pick any daily lifestyles, so just simply make it really user friendly, so user can get the most of the benefit from it. So that FIP you can use it, and obviously you should do something instead of the API calling. Just like this, you can just configure this Gamma model in your own local, and you can fine tune it. So fine tuning is quite tricky task. So you'll be able to learn a lot. You will be able to learn a lot from the fine tuning. There are different parameter techniques of fine tuning. So PEFT, there's a PEFT method, there's a low rank method. So different kind of fine tuning methods are available. So you'll be able to learn about them as well. So explore different terminologies about the fine tuning. So once your model is fine tuned, how you're going to boost it, how you're going to use in the application. So it's not about the idea, it's about how you're going to implement this as well. What are the technologies? If the technologies is just like API calling, then it means you're just simply calling the API. But with the instead of the API calling, you are just simply fine tuning. You are integrating the RAG as well. You are simply creating the agent as well. Fine tuning is really a quite resource and quite time intensive task. It's not simple and very straightforward. I can show you. In fine tuning, first you have to prepare the data set. Just like if you train a machine learning model, in machine learning model, you prepare the data set, you perform all the pre-processing and data pre-processing tasks before training the model. So same like in the fine tuning, you go with this. You have the pre-processed data set and you pass it to the model. And model take a long time to learn from the data based on the resources. I was trying to create an agentic framework, create an agents that can use the Gemma as a brain to perform the specific task. So let's say you have two, three different agents. Instead of using the any API, I was just calling this agent, this language model inside my agent to perform the certain task. So I was creating an agent. First agent is used to take the input from my user. I have to create a website. So the first agent is used to perform the requirement gathering task. Second agent is used to note down all the requirements into the functional requirements. Third agent is used to generate the task for the requirements we have gathered, and now we have to convert those requirements into the code. So the third agent is used to write the code for the requirements. I was using the ADK. Yes, you guys can get this notebook after this session from the Ali. The
Sure, I'll post it on YouTube description.
I think that's it. You guys don't have any further questions. So, guys, thank you for joining this session. I hope you guys learned about the Gamma, which is a open source, open weight model from Google. It has different variants. The Gamma family has different variants. According to your use case, you guys can decide. Those who are going to prepare the FYPs, you guys can utilize this in your FYP, because obviously being a student, you don't have the really the Google credits and any language model credits. So just install this language model in your own machine, and you can just simply leverage the usage of language model in your application. Another question? Well, it depends on your use case, which use case you're trying to solve. In real estate area, you have the data set, you have the geographical data set. If you want to analyze the data, it can, as you can see, this Gemma model have the multi-model. They can just simply go over the different type of data set, textual data set, image data set. So it can analyze the data set as well. If you want to understand perform the sentiment analysis on a very big level, on a very big data set, it can perform. You want to analyze the based on the specs of the property, you want to perform the which area is good, you want to perform the price estimation. You can also do this with the real estate area. But as in the real estate, we involve the geospatial data. When you have the data set, you must have the geospatial data. So you can observe this geospatial data through these language models as well, very well. So they can understand, they can find out what the humans cannot. They can go over every single detail very well.